Hi, hello, namaste. Today we are going to discuss about isomerism. Isomerism. So, what is isomerism? The compounds, the compounds have same molecular formula. Same molecular formula, different chemical structure, different chemical structure and properties, chemical structure and properties are called as isomers, and phenomenon called as isomerism. The compounds have same molecular formula, different chemical structure and properties are called as a isomer to each other, and phenomenon is called as a isomerism. Then this isomerism again divided into two types. One is structural isomerism. And second one is a stereoisomerism. So what do you mean by structural isomerism? We will discuss. The compounds have same molecular formula, different in entirely opposite arrangement of atoms. Entirely arrangement of atoms is called as structural isomerism. It means the compounds having same molecular formula, different in entirely opposite arrangement of atoms. It means there is not small changes, entirely opposite changes are called as a structural isomers, and phenomenon is called as a structural isomerism. Then coming to stereoisomerism. Then the compounds have same molecular formula, different in partial arrangement of atoms. Arrangement of atoms is called as stereoisomerism. So when we see this entirely opposite arrangement of atom, here this partial different in partial arrangement of atoms. This is a difference between structural isomerism and stereoisomerism. Then coming to this classification of structural isomerism. Structural isomerism. So the structural isomerism again classified into different type of isomerism. So first one is a chain isomerism. Chain isomerism. Second one is a positional isomerism. Positional isomerism. Third one is a functional isomerism. Functional isomerism. Fourth one is a metamerism. Metamerism. Not metamerism isomerism. That is the metamerism. Next one is a tautomerism. Tautomerism. Sixth one is this ring chain isomerism. Ring chain. And maybe chain ring isomerism. Ring chain isomerism. Either maybe chain ring isomerism. Then this stereoisomerism again classified into two types. Stereoisomerism again classified into two types. So first one is a geometrical isomerism. Geometrical isomerism. And second one is an optical isomerism. Optical isomerism. So this is the classification of isomerism. In structural isomerism means the compounds having same molecular formula, different in entirely opposite arrangement of the atoms are called as a structural isomer to each other, and phenomenon is called as a structural isomerism. The stereoisomerism, the compounds having same molecular formula, different in partial of the atoms are called as a stereoisomers, and phenomenon is called as a stereoisomerism. Then the structural isomerism again classified into chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, ring chain isomerism. Next one is a structural isomerism again classified into geometrical isomerism and optical isomerism. We will discuss each and every one by one. Coming to chain isomerism. Chain isomerism. Chain isomerism. So what do you mean by chain isomerism? The compounds have same molecular formula, different in arrangement of chain, arrangement of chain are called as chain isomers. Chain isomers, and phenomenon called as structural isomerism. Phenomenon called as chain isomerism. Chain isomerism. isomerism. We'll see one example. We'll see one example. CH3, CH2, CH2, CH3. This is the name of this one is a butane. Butane. We'll see one more example, that is the CH3, CH3, CH3. So this is the name of this one is a isobutane. Butane, isobutane. Then how many number of carbon atoms are there? We'll see. So which is having 1, 2, 3, 4. C4 carbon atom and hydrogens 2, 3, 3 plus 2, 5, 5 plus 2, 7 and 3, 7H, 10 hydrogen atoms. Then same to same. So C 1, 2, 3, 4, C4 carbon atoms and hydrogens 3 plus 3, 6, 6 plus 3, 9, 1 and hydrogen atoms are 10. So this type of the compounds. So having same molecular formula, different in chain. That means which are having straight chain, which are having substituted chain. So are called as a structural isomers and chain isomers to each other, which is comes under the structural isomerism. Next one is on positional isomerism. So positional isomerism. We'll see the position isomerism. The compounds having, so positional. Second one is a positional isomerism. Positional isomerism. The compounds have same molecular formula, different in position of the substituent or functional group is are called as functional isomers, are called as positional isomers. And phenomenon called as positional isomerism. So we'll see one example. So positional isomerism. For example, we will write this one: CH3, CH2, CH2, CH3. So we'll write this the chlorine. So what is the? It is a 3-chloro. Either maybe 3-chloropentane. 3-chloropentane. We'll see same CH3, CH chloro, CH2, CH3. CH3. This is a 2-chloropentane. 2-chloropentane. So the same to same molecular formula. It means when we see the C5 and 3 plus 2 5, 5 plus 1 6, 6 plus 2 8, 8 plus 3 H11 and Cl. Same to same. C3 H11 Cl. Cl. So same molecular formula, different in position of the. It means 1, 2, 3. 3-chloropropane. So when we see the 1, 2-chloropropane, 2-chloropentane, 3 2 chloropentane and 3 chloropentane. The position of the substituent will be changed. This type of isomers are called as a positional isomers, and phenomenon is called as a positional isomerism. We'll see one more example. So this is a 3-pentanone, and this is the 2-pentanone, 3-pentanone. So what is the thing? Same molecular formula. It means C1, 2, 3, 4, 5, C5 hydrogens, 5 plus 5, H10 and O. So when we see 1, 2, 3, 4, 5, so C5, H1, H here 2. CH3, 3 plus 2, 5, 5 plus 2, 7, 3, H10, O. So same molecular formula. So here keto group present at third position, keto group present at second position. Hence they are called as a positional isomers to each other. And position of the keto functional group present at third position, position of the keto functional group present at second position, and this type of isomerism is called as a positional isomerism. Then coming to third one is a functional isomerism. Functional isomerism. Functional isomerism. The compounds have same molecular formula, different in functional groups. Functional groups are called as functional isomers. And phenomenon called as functional isomerism. So for example we will see for example. So this, for example, CH3, O, CH3. So that is a dimethyl ether. Dimethyl ether. The functional group present in it is ether. And coming to one more example, CH3, CH2, OH. So this is a ethanol. So name of this one is a ethanol. Either maybe ethanol is a ethyl alcohol. So the functional group present in it is a alcohol. So then what is the molecular formula? C2H6O. C2H6O and C2 3 plus 2 5 plus 1 6 H6O. So which are having same molecular formula, different in functional group, which is an ether functional group, which is an which is the alcohol functional group. Hence they are isomers to, they are isomer, functional isomer to each other, and phenomenon is called as a functional isomerism. Then we will see one more example. So we will see one more example. Then that is CH3 C double bond O CH3. This is the name of this one is a acetone, and it is in a ketone functional group will be present. Then we'll see one example, one more CH3 CH2 C double bond O H. So what is this? Propanaldehyde. Propanaldehyde. Then aldehyde functional group will be present in it. Then what is the formula of this one? C3H6O. Then how many number of carbon atoms are there? C3, 3 plus 2, 5 plus 1, 6, H6O. And same molecular formula, different in functional group, in which ketone functional group will be present, in which aldehyde group functional group will be present. Hence they are isomers to each other, and phenomenon is called as a functional isomerism. Then coming to metamerism. So metamerism. We'll see about metamerism. So the compounds have same molecular formula, different in unequal distribution of carbon chain, either sides of functional group. Is called as are called as metamers. Phenomenon called as metamerism. So this is the one of the functional isomerism only. So what happened? Metamerism means the compounds have same molecular formula, different in unequal distribution of carbon chain, either sides of functional group. Either sides of the functional group are called as a metamers, and phenomenon is called as a metamerism. For example, we'll see one example. CH3 CH2 OCH2 CH3. So diethyl ether. So it is a diethyl ether. And next one is a CH3 OCH2 CH3. So that is a methyl propyl ether. So when we see the same molecular formula, so for example 1 2 3 4 C4, 3 plus 2 5, 5 plus 2 7, 7 plus 2 7 plus 3 7, H10 O, and 1 2 3 4. So C4 H hydrogen, 3 plus 2 5, 5 plus 2 7, 7 plus 3 H 10 and O. So the compounds having same molecular formula but same functional group will be present in it. But here the equal. So equal. So two carbons this side present and two carbons this side present. Then this unequal distribution, here equal distribution, here unequal distribution. So this side one carbon is there, this side three carbons is there. So this type of unequal distribution present in a compound. Both are, these two are the isomer to each other, and phenomenon is called as a metamerism, and they are called as a metamers to each other. Next, coming to, we will discuss about tautomerism. 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 So the compounds having same molecular formula. Same molecular formula. Same molecular formula. Same molecular formula. Different in position of hydrogen, or the compounds having same molecular formula. The compounds have same molecular formula, different in position of hydrogen or electron. Different in position of hydrogen or electron are called as tautomers. And phenomenon called as tautomerism. Tautomerism was most important one. It is an interconversion reaction. It is an interconversion reaction. So hence we'll see one example. For example, this ketone CH3 C double bond O CH3. So CH3. So I'm writing this CH3 like this. So when these electrons are shifted towards itself, this will be atom and it will be converted into CH3 and COH and double bond OCH2. So it is a keto group will be present, and enol group will be present. Enol group will be present here. It is called as enol and it is called as keto. So it is always happen interconversion reaction. So the keto will be converted into enol and enol will be converted into ketone. Hence it is called as a ketoenol. Keto enol isomerism. Ketoenol isomerism. So this is about tautomerism. So same molecular formula, different in position of hydrogen or electron, which is the most important. When we see the position of hydrogen in ketone group will be present at this carbon atom, and the position of hydrogen which will be present at oxygen atom. This type of isomerism is known as tautomerism, and phenomenon is called as these compounds are called as a tautomers. Next one is Next one is an ring chain isomerism. Ring chain isomerism. Ring chain isomerism. The compounds have same molecular formula. Same molecular formula. Different in closed chain system, closed chain system or open chain system. Are called as ring chain isomers. Ring chain isomers. Phenomenon called as ring chain isomerism. So we'll see the example. CH2. This ring system will be present. Name of this one is a cyclobutane. Then we'll see CH2 double bond, CH2, CH3. So that is the butene. Name of this one is a butene. So, for example, there's a molecular formula C1234 C4 and H8. C4H8. When we see C4H 2 plus 2 plus 2 6. Sorry, mistaken. 2 plus 1 4 3 3 plus 2 5 5 plus 3 H8. So they are have same molecular formula. Different in open closed chain system as an open chain system are called as a ring chain isomers, and phenomenon is called as a ring chain isomerism. Then coming to geometrical isomerism. So, geometrical isomerism. So, what do you mean by geometrical isomerism? The compounds have same molecular formula. Different arrangement of atoms around the double bonded carbon atom. Are called as geometrical isomers. And phenomenon is called as Geometrical isomerism. Geometrical isomerism. Isomerism. So we'll see one example, that is the CH, C, double bonded C, double bond C, and chlorine over here, H over here, chlorine over here, and H over here. So there is the dichloroethene. So we'll see same. So double bond C and chlorine over here, and hydrogen here, So this is also dichloroethane. So the same. So when see the same to same molecular formula having same to same structure, the partial arrangement of the atoms. That means when we see these two chlorine atoms are same side in the plane, same side, and then it is called as a cis. So cis dichloroethane. Then these chlorines are opposite side, hence it is called as a trans dichloromethane. Hence this type of geometrical isomerism is called as a cis-trans isomerism. Cis-trans isomerism. Cis-trans isomerism. So, hence, this type of isomerism especially seen in double bonded carbon atom, either maybe alkenes, all are seen in alkenes. Next, coming to last one is an optical isomerism. Optical isomerism. Optical. So the compounds have same molecular formula. Different in arrangement of atoms. So different arrangement of, so which different, partial different. So different arrangement of atoms around single bonded carbon atom. Carbon atom are called as optical isomers. And phenomenon called as optical isomerism. So we'll see. So for example, we'll see one example. CH3 and H and chlorine. So we'll see, this is a dichloroethane. Name of this one is a dichloroethane. Then same carbon atom, which is having same thing. So CH3, Cl, H. So for example, this is also dichloroethane. As maybe we'll see one more example. We'll see one more example. Bromine. One chlorine, one bromine. bromine, chlorine and hydrogen. So the name of this one is a bromochloroethane. Bromochloroethane. So this carbon contains 4 different groups. When we give the priority, the methyl group given first priority, then bromine group given second priority, third group given third priority. So when we connect this one, this comes under like this 1 to 2, 2 to 3. Based on the molecular weight priority. Then which will be in this, which will be given first priority, which will be given second priority and which will be given third priority. So when we see that which will be structure, which will becomes this like structure. So it will be showing like a clockwise structure and it is showing like a anti-clockwise structure. Hence they are called as a dextrorotatory compounds. Dextrorotatory, it is indicated with the plus, and levorotatory compounds and it is indicated with the minus. So what are these optical isomers? So these two are the example, which is a dextrorotatory compound and which is a levorotatory compound. So what are these optical isomers? What do you mean by dextrorotatory compound? What do you mean by levorotatory compound is discussed. So the compounds which in dextro, the compounds which turns the compounds turn the plane polarized light, right side, either maybe right side are called as dextrorotatory compound. The right side means dextrorotatory compound. So which will be right side means either maybe it is called as a clockwise, either maybe right side. Then the compounds turn the plane polarized light, anti-clockwise. So anti-clockwise means left side are called as levorotatory compound, levorotatory compounds and called as a levo compounds. So this is about we already seen this example. So this is about the optical isomerism. So if you like my video, please like it. If you want any explanation about any topic, you can comment it. And if you want notification about my videos, please subscribe my channel, my tutorial channel, JBchem tutorial. If you want any explanation, make a comment. Thank you one and all.